Okay, so in this video, we're going to do like everything, man. Okay, I've got a couple of examples here of, let me just show you the list. We're going to find vertices and intercepts and axis of symmetry, domain, range, intercepts, intervals of increasing, decreasing, and we're going to switch forms of quadratic equations. So if I'm in standard form, I have to get it into vertex form. If I'm in vertex form, I have to get it into standard form. And then we're also going to graph. So everything, man, all of it. We're going to do it with these two equations. So I notice that this one is in standard form and then this one is in vertex form. So I just want to kind of show you a few examples of, all the different questions I guess you can be asked with quadratics. So let's start with the first one. Okay, so I've got to find the vertex, intercepts, axis of symmetry, domain, range, intervals of increasing and decreasing. That's a lot. I think the easiest way to approach questions like that actually is to first get the equation in vertex form. So to get it into vertex form, I have to complete the square on this. And I have a whole video where I explain how to do that. So I will just kind of summarize what you do. So the way I like to approach this is I like to isolate the x's first. And before I can even do that, actually, so I need a leading coefficient of 1, which I do not have. I have a leading coefficient of -1/2. So when that happens, the very first thing that you want to do is just do whatever you have to do to make this a leading coefficient of 1. So this is a fraction, -1/2. So what I'm going to do is I'm going to multiply everything by -2, like you see here, everything. And then that will allow me to flip my leading coefficient. Now, you'll notice I even multiply the function by -2, and I know that looks kind of weird. I like just holding this side as a placeholder and then sorting this out at a later time. I think that just makes everything easier. If you've learned to complete the square in the past, some books talk about like a different process when you're working with functions. Personally, I think it's just easier just to manipulate f of x and then we'll solve again for it later. So if you're kind of wondering what am I doing with this, you'll see in a few minutes. Okay, so anyways, so now I want to isolate these two x's, so I'm going to subtract off the 1. And so this just kind of gives me a nice picture of where I want to complete the square. So I want to complete the square on the left side. And so to complete the square, I just look at what is next to the x, so that's a 6. So that's going to be my b. My b is equal to 6. Then I take half of b, which is 3, and then I square that result. So half b squared is equal to 9. Okay, so now, whatever my half b squared is, I add it to both sides. And so now I have -2 f of x plus 8 equals x squared plus 6x plus 9. And so the thing with completing the square is the whole intent is to write this thing right here as, a square. So this becomes -2 f of x plus 8 equals x plus 3 squared. The thing I like to remind people of is if you're not sure of how to factor this, what you write here is always whatever your half b is. Okay, so now that I've completed the square, I have, the left side looks kind of weird. So now what I want to do is I want to solve for f of x. So the first thing I need to do is subtract the 8. So this becomes -2 f of x equals x minus 3 squared minus 8. And now I want to get f of x by itself, I need to divide everything by -2. And okay, so let me clear a little space. Okay, and so now I've got f of x. I like to write this part here. I want to interpret dividing by -2 as the fraction -1/2. Makes it easier for graphing, and then this will become +4. So look at what I've got now. Now I've got this nice vertex form, so I can answer a lot of questions. So let me just clear this space now so we can see the two equations that we're left with. Okay, so these two equations are equivalent to one another, but one form is better for answering certain questions, and then the other form is better for answering other questions. So when I'm asked, like, what is the vertex? I can tell that from the vertex form. It's just going to be 3 positive 4. So it's just this, the opposite symbol of this, and then this. So there's the vertex. And then I can also get the axis of symmetry from this. So the axis of symmetry, the one thing you want to remember with that is that it's x equals, so you have to have it as an equation. It's not just a number. Okay, so the next thing I want to do now is I want to figure out what are my intercepts. So I think this is where actually like having this form of the equation is nice, because it's easier to find a y-intercept in this form of the equation, because think about what it is to plug 0 into this versus plugging 0 into the second equation. So knowing both, if you're being asked a ton of questions like this, it just, like I said, it's some forms are easier for certain questions than others. So what I'm going to do now is I'm going to plug 0 into that first equation. And so now I can say that my y-intercept is 0, -1/2. So that was a much simpler calculation to do. Now, finding the x-intercepts. Since I have two forms of the equation, so to find an x-intercept, what you need to do is you need to set the equation equal to 0 and solve. Now, the thing is, I think in this particular example, I think that this equation might be easier to work with. Because this one, I think you're going to have to use the quadratic form on. This one, you can use the square root property. So think of all the different ways that you know to solve quadratics. I have videos on it. Like all of those different ways you can solve quadratics, they all come into play now to find x-intercepts. So it's kind of the Wild West when you're solving x-intercepts. And so you just have to kind of look at it and say, okay, what do I think in this situation would be the easiest? So what I'm going to do is I'm going to set this equation equal to 0. But you could have set the first equation equal to 0 and solved it, and you should get the same answer. So if you want to go the other way, you can totally do that. All right, so now what I want to do is I want to just use the square root property. So let me clear some space. And so to use the square root property, I need to isolate this thing right here. So the first thing I'm going to do is I'm going to subtract 4. So this becomes -1/2 x minus 3 squared equals -4. And then I'm going to multiply both sides by -2 to cancel out the fraction. So now I have x minus 3 squared equals 8. And now I can take the square root of both sides. Now when I take the square root of both sides with the square root property, remember you put a plus or minus in front of the square root sign. So ultimately, what I get then is this is x equals 3 plus or minus the square root of 8, and the square root of 8 can be 3 plus or minus 2 times the square root of 2. So we have two x-intercepts in this case. So let me clear some space. Okay, so the first x-intercept will be 3 plus 2 square root of 2 comma 0. So remember, we set the equation equal to 0. That means we set the y equal to 0. The second x-intercept will be 3 minus 2 square root of 2, 0. So I'm literally taking those 2 points from this right here. Okay, so let's see how we're doing on that list. So we did the vertex, we got the intercepts, axis of symmetry. We still need the domain, range, and intervals of increasing, decreasing. We did switch between the two forms. So we've got both forms of the equation. So I think that the next part of these questions, it's easiest if you have the graph. So let me clear some space. All right, so to graph, which form is better to use? Well, I think this is the better form for graphing a parabola. So, all right, let me just get my graph set up. Okay, huzzah, there we go. So, all right, I have my vertex will be at 3, 4, right here. And then this parabola needs to open down because there's a negative here. And so instead of going out 1 and down 1, I'm going to go out 1 and down half, because that's what the half here means. So I go out 1 in each direction and then just down half. So I've got my parabola. Let's see if I can draw it. Boom. Okay. So I've got my little sketch now, and I think this is going to make everything easier. So I still need to find the domain. So the domain of a parabola in general is just all real numbers. So remember, domain means how far are you going to the left and to the right? Where are you going on the x-axis? So we're going to cover the entire x-axis. So the domain is just all real numbers. So it's just -infinity to infinity. The range, however, is a little more interesting. So the range has to do with your y values. So we go from the bottom to the top. So I go from the range, so I start down here. And so this just goes down here for forever. So this is going off in the -infinity direction. So this starts at -infinity, And then it continues all the way up, 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 boop, until we get to right here, right? And so this is the vertex. So my range stops at 4. That is the top spot. 4 is included, so it gets a square bracket. All right, so now for the intervals of increasing and decreasing. So when you do intervals of increasing and decreasing, by the way, you want to use the x values. That's what we're talking about where it's decreasing on the domain. So when I'm increasing, so increasing is going this direction. So I'm increasing from here all the way up to this point. So remember, this point, just to help you out, because it can get a little confusing, where are you using the x or the y? We're increasing all the way up to the x. So I go from negative infinity up to 3. 3 will get a round bracket because this is where the increasing to decreasing changes. So 3 does not get included. So I increase to this point, and then from here down, so from 3 to infinity, I am decreasing. Whew, all right, that was a lot of work, but we got it done. So let's do it all over again. All right, so for B here, so what I want to do first is I like to switch forms first, just so I have all that information. So the question is now, how do I go from the vertex form to the standard form? Well, this is actually pretty straightforward. There's nothing that you have to solve. You really just have to do the math here, so I have to FOIL this whole thing out. So if I work this out, let's see, this becomes 2 times x squared minus 2x plus 1 plus 3, and then I can distribute the 2. So I have 2x squared minus 4x plus 2 plus 3. So then this simplifies to 2x squared minus 4x plus 5. All right, so there is my standard form of the equation. So now I can try to answer a bunch of questions off of this. So let me clear some space. All right, so first we find the vertex, which I can figure out from the vertex form. So what I would challenge you to do is see if you can find the vertex, axis of symmetry, and then also try to find the x and y intercepts. If you're watching this video, then you're probably watching it because you're struggling with this a little bit. I showed you how to do it in the other example. Just give it a try. The worst thing that happens is that you get it wrong, no problem, but you learn more from your mistakes, so hit play when you think you're ready. So my vertex is 1, 3, so I get that from the vertex form. It's always the opposite of whatever your x is in 3. The axis of symmetry, remember that has to be an equation, x equals 1. Now, for my y-intercept, I can just plug 0 into this equation here. That's probably the easiest. So if I plug in f of 0, so just looking at this, this becomes 0 minus 0 plus 5, so this equals 5. So my y-intercept is 0, 5. And then, now for kind of the trickier part. So how to find your x-intercepts. So looking at the two equations, this does not factor, right? So this, that's kind of what I'm looking for. If this were to easily factor, then I would set this equal to 0, but since this does not easily factor, I'm going to set this form of the equation equal to 0. So let's see, I'm going to have 2 times x minus 1 squared plus 3 equals 0. So I'm going to use the square root property again, so I need to isolate this part right here. So first I will subtract off the 3, oops, and this should be a 2. And then I will divide both sides by 2. So I have x minus 1 squared equals negative 3 over 2. And then when I take the square root of both sides, so let's just talk about what this means. So notice now I'm taking the square root of a negative number. So this is imaginary. So when this turns out to be imaginary, what that means is there are no x-intercepts. The second you get an imaginary number in that, you could just say right away it's no x-intercepts. So let me clear some space and write that. Okay, so we've gotten through a lot of this information. So the next things that we need are, we still need to get the domain, range, and intervals of increasing and decreasing, which I think is easiest if you graph, which we have to graph anyways. So let's clear some space. All right, and so now I've got my little graph here. So I can use this equation. So I need to move right 1 and up 3. And then normally I would go out 1 and up 1 to draw a parabola, but since I have this 2 here, I'm going to go out 1 and up 2 in each direction. So there's my parabola. Okay, so no x-intercepts, cool, aligns with the information we've already found. So next, the domain. So the domain of parabolas are always all real numbers. The range, however, so my y values start here and just keep going up. So this starts at 3, and 3 is included. Then we continue on to infinity. Now, the intervals of increasing and decreasing. In this case, my parabola is decreasing, decreasing, decreasing up until this point. So this starts at negative infinity and then decreases until it hits the vertex at 1. And then it continues on from 1 to infinity. Okay, and so that covers everything. So hopefully those 2 examples were helpful. So I'm going to leave the video here. You can always leave comments or give a like or whatever. Thanks for watching, guys. I'll catch you next time.